Well, good afternoon. I would like to welcome everyone to our webinar program today. Today's topic is dealing with the installation and maintenance of on-farm solar photovoltaic systems. I will mention at this time that this is part 5 of an ongoing weekly program webinar series that we're going through this season. We've touched on a number of topics to date, and if you were unable to catch those previous sessions in past weeks, we've touched on Maryland solar market, the basics of a solar PV system, and looked at the different components, planning and design work, and in weeks past we've done a little bit on permitting, and we'll kind of continue on a little bit of that aspect today, as well as we look at actually installing a system. We'll look at some of the technical aspects of installing a solar PV system, as well as the permitting requirements as well. And we're going to fly at a high level over some of these topics and hover over others, but hopefully touch on some interesting topics today. As you're kind of waiting for others to join the program today, I'll start with an introduction of who I am. My name is Drew Chavon. I am an extension specialist with the University of Maryland. My background is in agricultural engineering, working on a variety of energy efficiency technologies and clean energy technologies. Of course, that would include solar photovoltaics, primarily within the agricultural sector. But my experience in our programming through the University of Maryland Extension is rather diverse. You can find out more information about this ongoing webinar series that we're doing on our website. That's extension.umd.edu/energy. We have a number of other resources on there as well, so you can find out more details there. The recording for our previous sessions are on there, as well as the associated materials that go along with it, our slideshows and other materials. So if you've missed those previous sessions, you can go on our website and get more information there. And you can also register for upcoming sessions as well on our website. Next week, I think, is dealing with the economics and financing of solar photovoltaics. So if you're interested in that, please connect with us on our website. My contact information, again, my name is Drew Chavon. The contact information, email, and phone number are listed on the slide presentation I'm sharing with you. So if you want to reach out to me at any point, please do so. So as we get into the topics today, I'll just start by giving you a brief introduction of the format. I'll mention this is being recorded, as all of our sessions are. So if you missed part of it, you can go back on to the website and rewatch the video or get the resources. If you do have questions, please put those into the Q&A feature on the Zoom, and I'll do my best to answer those questions as we wrap up at the end of our hour today. At this point in time, before we get into the content, I'm going to issue a survey, as I usually do. It has several questions on there, and this will help us to identify who we have joining our program today, so that we can cater today's program and future sessions around your specific needs. So you'll see 3 questions on your screen. One is who we have joining us. I imagine we have some farmers joining us, and others as well. Please indicate there. Question 2 or 3 are specific interests that you might have in the specific technology. So please indicate your answers there, and then click the submit button, and I'll give you just a moment to complete those questions before we dive into our subject today. I'll give you about 10 more seconds or so to get your responses in. Okay, so I am going to wrap this up now in the poll. Appreciate everyone's input on that. That's certainly helpful. Now we'll kind of look at what we're going to touch on today. And as I said, there's a number of topics that we'll hit today. It'll be kind of a lot of content for us to cover. We won't be able to go into depth on every issue, but I'll highlight some of the important aspects as we start to design and implement and install a solar PV system. First, I'm going to touch on energy efficiency. It's a topic that has come up in previous sessions of this webinar series. And I don't want you to tune this out because I think it has tremendous values. Saving energy up front not only saves you that money directly because you're using less energy, but also then as you go to design and install a solar PV system, you're using less energy, so you're going to need a smaller system, and that's going to save you money on the investment of that solar PV system. So I will take a couple minutes as we get started, just re-emphasizing the importance and priority in being more energy efficient. And you'll see how those two technologies, energy efficiency and solar photovoltaics, how closely those two energy measures are coupled together and how they kind of go hand in hand. And then we'll get into more specifics on the installation. So what I typically share is aiming for those lower hanging fruit, the different measures that you can implement in your home, farm, or other business to save not only energy, but the economics associated with it. Aim for those low hanging fruits that have a quick return on the investment. And so I share this illustration, and I've done so in the past. Typically, it's best to start with those categories that are lower down in that illustration. So at the bottom of that triangle, you'll see what's called energy analysis. And really what all that is kind of taking a look at where energy is being used on your farm. So this could be done with a formal energy audit. You could have an auditor come onto your farm and evaluate where energy is being used. And that'll give you a better understanding of not only how you can save energy through energy efficiency, but then design a PV system around that. This could also be kind of a self-assessment, do-it-yourself assessment of your energy use. You might just be interested in looking at the lighting system or the heating or motors or something like that, or you could look at the overall system. But in any sense, that bottom level is kind of an assessment, but then as you progress up through that illustration, you'll notice more active measures taking place, such as energy conservation. And I've mentioned this before, but energy conservation is simply turning the light switch off. And that would be saving power or energy rather, because you're not using the energy. If the light switch is turned off, you're not paying for any of that electricity. It's a behavioral change for sure, and there's no investment involved in it as such. So you are saving energy right up front. But again, the less energy that you're using, then the smaller your solar photovoltaic system will be. And we've talked about the design work behind that. We've used different software, PV Watts, in previous weeks. You can design a system around that. But this is important to save energy up front before you get up to those higher tiers. If you look at the top, is that renewable energy category. That's typically going to have your slowest return on your investment. It's rather expensive depending on the technology. And that's where solar photovoltaics would fit in, is that higher category. So we want to aim for some of those lower areas first. I've included a common expression here on the slide. It's the cheapest energy is the energy that you don't use. Okay, and I think that's a good mentality to have, because if you're not using the energy, then you're going to be saving money. You're going to be designing a smaller PV system. On the diagram of this bar chart, you'll see that the levelized cost of energy efficiency, and that could be a variety of different technologies, but that's typically going to be far less expensive in the long run than any of those energy resources like is included here: wind, utility scale solar, community solar is there. But energy efficiency is typically the most economical to start with. This is another bit of information that I've shared previously. This is kind of a snapshot of what energy use might look like on different farms. Every type of farm is going to be a little bit different in terms of their energy use. And even from one farm to the next, your energy use is going to be a little bit different. So it does take some assessment, going back to that energy analysis, understanding where your energy is being used. But I will say there's some common trends you can see. For one, you'll see that mostly the heating and cooling, basically all your HVAC and ventilation components are using the most energy. That's in most operations. And the same I could say for residential and commercial operations as well. That's typically the largest area of expense, is your space, heating, and cooling. So typically you want to target these areas when you're trying to be more energy efficient and save money. You want to hit these larger areas first because you're going to see the greatest impact from there. It's not saying some of the other areas like lighting won't see improvements, and we'll actually go through an example in a few moments on the benefits of improving the energy efficiency of lighting in particular. But you want to target those areas on within your operation that are going to see the best return on your investment. Again, that starts with an energy analysis. So I'll provide some resources, and I won't go into too much detail because really today's topic is dealing with the installation of solar PV, but I'll just share some of these resources to help you get started on energy efficiency. On the left-hand side, I've included a list of utility providers and their energy efficiency programs. Now, most of these are going to be geared towards residential energy programs. They can connect you with rebates, incentives, helpful tools and resources, and also energy auditors. Now, again, most of these utility providers are going to be more geared towards residential. You will see some programs, depending on your specific utility, that are geared more towards commercial and some overlap with agricultural. But I'll just throw out, if you do connect with an energy auditor or are interested in pursuing that, just make sure that you're not having someone inexperienced with an agricultural operation perform that audit. It's not like a residential energy auditor is well prepared to perform an agricultural audit. But there are those, some available in the area, and we can connect you with that if you're interested. But this information here is more towards residential, as I said. In the center of the page, you'll see I've included a resource from Colorado State University. This is a helpful tool. There's many others, but this is one in particular I appreciate. And if you want to visit their website, it's kind of a walkthrough, do-it-yourself audit geared towards a residential market, and you can go category by category and look at ways to improve energy within your home. Now, I'll also share resources for the agricultural side. Again, a resource from Colorado State University. They have good information here about saving energy in various places on your farm. So you can indicate on the front page, there's check boxes for if you're interested in lighting improvements or field operations or anything in between. So that's another good resource. And two questions that I'll kind of put out there as good for you to consider when you're thinking about energy conservation on your farm is what uses energy on your farm and what uses the most energy. Again, you want to target those areas that are most inefficient. And so that could be, even as simple as maintaining your fans for ventilation or your motors or pumps, keeping those in good working condition so that they're operating efficiently, and you'll see a savings there. And you also want to look not only at one moment in time, but there's seasonal differences in our energy use throughout the year. So in the winter, now that we're going into colder seasons, we're going to be using more heating resources. And so you want to be able to capture different seasons in that picture as well. But there's a number of tools there. If you have more questions on that, you can certainly reach out to me and I can help you kind of navigate some information in that area. Another resource is just going right to your utility bill. And we've looked at this example previously, but if you don't perform a full energy audit on your farm, you could go through your utility bill and see month by month energy use. And this is in fact how we designed our PV system in a previous session based on the information we got from the utility bill. So you can go back and review that if you'd like to do so. Another resource is on our Maryland Energy Extension website, a number of ways to save energy on the farm, including a Microsoft Excel spreadsheet that you can download. This is a helpful tool to put in different energy that you might be using on the farm, not only electrical energy in terms of kilowatt hours, but also if you're using diesel or propane or natural gas, you can put that in there month by month and record it, and it'll generate a graph showing your energy use through the year. So again, this is another useful tool that shows the energy use and helps you then to design a PV system. There's many other tools out there. One more in particular I'll mention is Wyoming extension. You can print this PDF out, and it's basically a chart where you can put in different devices that are using energy. So the example they give is for a flat screen TV, but you could just as easily put a lighting system or a motor or a pump in there and evaluate how much energy that system is using. So those are just various tools. And I'll briefly share an example, and then we'll pivot more into actually installing a solar PV system. So this is an example of a poultry housing operation. They're wanting to replace their existing tube lights with new energy efficient LED bulbs before they even consider solar photovoltaics. And so they're taking 110 bulbs. Those are 75 watts each. And that comes out to just under $6 a day to operate those lights. That's not including any other ventilation or any other energy usage, just lights. $6 a day almost for those tube lights, and replacing those with LEDs. In this case, they'll only need 55 LED bulbs because that matches the same light output in terms of the lumens. So not only do they need less LED bulbs, but the power rating of those bulbs is also less. In this case, it's only 40 watts. So fewer bulbs and less wattage means that the kilowatt hour, you're paying the same rate, but the price for that kilowatt hour is significantly lower. It's a savings of over $4 a day, which doesn't seem like a whole lot, but this is something that's done 365 days a year. Those lights are operated, so it does add up. So there is quite a bit of savings there. So you save that money up front each month as you pay your bill. But then, again, I'll re-emphasize that point that now when you design your solar photovoltaic system, you're not using as much energy, so you don't need as large of a system to install. Now, I'll mention, yes, energy efficient measures. With this example, with the LEDs, it does require some investment. There are rebates and incentives. That's a topic we'll talk about next week. But if you were to pay for this particular example, these LEDs up front, right out of pocket, it'd be about $3,500 in this case. So without any incentives, without any rebates, it's going to take a payoff of less than 2 years. Hopefully you've offset that with some rebates or something of that nature, but it'll take a little time to pay off. So that's part of it. But in the long run, you do save money with these kind of measures. So like I said, I don't want to take too much more time on that. I want to jump into the actual installation aspect of our program today, and I think that's why most of us are online to join us. But we'll touch on a number of things from the site considerations. We'll look at partnering with a contractor and other issues as well, because it is quite an intensive process depending on the size and scale that you're installing. If you're looking at a small backyard system that's battery supported off-grid, that'll be a little bit easier than an interconnected grid-tied system. And there's some building permits and codes and other standards that we'll kind of touch on throughout the session today. So to kind of go off of what we've talked about before, you'll have to kind of consider the type of system you're going to install and where it's going to be installed on your property, if it's a rooftop or ground-mounted system. A couple of the constraints and considerations we've touched on previously have been associated with the tilt. And that's kind of how upright the panel or the module is sitting. So in the winter, it's typically best to have a more upright position on your tilt. In the summer, when the sun is up higher, you're going to lay it back more. Now, there are tracking systems. There are ways to tilt your panel, but any moving part that you include is going to cost a little extra. You will improve the efficiency by having that pointed directly at the sun, but the moving components are expensive, and they do require some additional work and maintenance to maintain. So we're not going to talk too much about the tracking systems. Mostly we're going to talk about the fixed systems. And for us, we're going to fix ours at about 39 to 40 degrees because that's the latitude that we're at here in Maryland. And you don't have to be exactly on that. You can have some deviation from that, especially when you consider a rooftop system. If you're putting a solar photovoltaic system on your roof, you're really kind of restricted to the slope of your roof. Yes, you could change the angle of your roof, but again, that's going to require additional material and supply to kind of change the angle to match our 39 degrees that we're aiming for. So It's typically best if you're putting it on a roof, just take the lower efficiency and get the angle of your roof to the best you can. Orientation is another aspect, being that we're in the northern hemisphere. We want to face our solar panels southward because the sun, regardless of what season it is, the sun is always to the south of us. Yeah, you can go a little east or west on it, but you're going to get the greatest efficiency over the course of the year and through the seasons. You're going to get it southward facing. So there are some restrictions with a rooftop system. Obviously, I mentioned the slope of the roof is kind of one area, but if your house or a barn or whatever you're installing on the roof of, if that's not oriented south, you're kind of restricted there. You definitely don't want to put it on the north side. If it's slightly to the east or west, that may be all right as well. But this is an area that we've kind of touched on in previous weeks, looking at PV Watts software put out there by NREL. If you want to go back and review some of those details, you're welcome to do so. The area and the size of the system, if you're building a really large system, is your roof going to support it structurally? Do you have the space on your roof to hold that? And it's not only the exact size of your roof, but you're going to have, depending on your jurisdiction, fire codes and spacing requirements that you'll have to meet. You'll have chimneys and pipes to work around. So you don't necessarily assume that you have your entire roof structure. What I'll say is with ground mounted systems, if you decide to go out into your yard or on your property and install a solar PV system, you can really tilt and orient that structure however you want in order to maximize the efficiency and production from the sun. So there are some benefits and trade-offs there, and we'll kind of touch on some of those as we go forward. Now, I'll say we'll spend most of our time today talking about solar for farms, and I want to kind of make a distinction there is using the energy from the solar photovoltaic system for on-farm use. And these are typically smaller systems, less than a couple hundred kilowatts, or we'll talk about some examples that are close to about 10 kilowatt systems. The larger operations, utility scale, or what we might call solar farms, are much bigger in the megawatt range. So the Public Service Commission of Maryland requires special permitting for 2 megawatt systems, those larger utility scale systems. We'll kind of touch on solar farms, those bigger operations, but it's a topic that we'll address more specifically in the future, not this week, but in upcoming weeks as well. But what I'll say is there are some similarities with how they're installed. What you're going to see with those larger systems, of course, there's more intensive permitting, management and upkeep and other things involved with it. So it's just a little bit more intensive building a large solar farm. Various aspects involved in site installation, and it's going to depend on what size system you're working on, what type of system you're working on, site surveying, geotechnical analysis, and so you'll have to look at the soil. If you're looking at a much larger system, you're going to have a professional engineer look at that, and a geotechnical engineer or something of that nature to kind of assess is the land suitable for supporting the system. And so those are some of the aspects we'll kind of navigate on a smaller scale for a backyard type system, or 100 kilowatts or less or something like that. It's not going to be as intensive, but you're still going to have building codes and permits and other aspects to deal with depending on the type of system you're building. So we'll kind of highlight some of those as we go through the program today. As I said, there's a couple options. Main categories here that I'll kind of mention is rooftop system, so a roof mounted system. The example I've shared on this slide is a single, basically a shingle system, and you have a metal flashing that slides under the shingles. You have an L-foot, which is basically an L-shaped bracket, and that actually has a lag bolt going through it, penetrating the roof into the trusses within your roof structure. So, this is just one manufacturer's product. There's many similar products and even some more diversity there in the market, but this is what a lot of systems look like with that L-foot. Again, anytime you're penetrating the roof, you have to make sure you get a good seal that water isn't penetrating into the structure. And so that's something you have to be on the lookout for. And I said there's different types of models there. But that L foot coming off the roof then is attached by nut and bolt to a railing. You see in the bottom photograph a rail going from left to right across the roof. That railing, that long railing, is what's actually what the module is actually, or the panel is actually mounted to. And so we'll look at an example of that momentarily. Pole mounted system is taking a tube or a pipe and putting it into typically a concrete footer. And the depth would be dependent on local conditions and the weight of the structure. And we'll look at some examples of that as well. And so that's a simple pole mounted. With the ground mounted are typically larger, requiring multiple piers or piles being driven into the ground. With a larger utility scale, you'll typically have larger machinery, either shaking or pounding or screwing the piers into the ground, and you're going to have more piers based on the size of the system. If it's heavier, you're going to have more supports being driven into the ground. With a smaller scale, you're still going to need equipment. You'll need an auger or something like that, depending on the operation. Some other examples here is, a concrete footer on the left. This is for a larger project, but what you'll probably see, I don't know how many cubic yards of cement that is, but if you're using cement like that, that can add up quite a bit, and it's not so attractive economically anymore. So typically that's why on a larger scale, utility scale projects especially, you'll see those piers or piles driven straight into the ground rather than having that concrete, such a substantial concrete footer. There's also a ballast system typically used on flat roofs, could also be ground mounted, and this is avoiding any penetration into the structure. So it's just weighed down with cement blocks or something like that. There's a lot of different options on the market. Here's another look at ballasted systems. On the left, you see a rooftop system or ground mount system or ballasted system on the ground rather. But different options, a lot of different manufacturers out there. Find what works for you and kind of explore those options. Another look at rooftop systems. Again, a shingle roof on the top there. You'll see the L foot and the rail attached to that. And the modules actually sit down on those rails, and you have different clamps that hold the modules down to the railing. So you have an end clamp with a lip on one side that holds the module down, or you have a mid clamp that has a lip on both sides, so it holds the module on the left and the right. And so there's different products out there. That's what a lot of those look like. There's options for different roof types as well. We see a lot here in the area of metal roofs with a standing seam. So there's an example of that option as well. And that just cinches down onto the standing seam of the roof. So that would be another option as well. Pretty much every roof type, there's options out there. We'll take a look at pole mounted systems here. And this is different because, you're building from the foundation up, literally. You're not starting with an existing structure. You're typically putting a concrete footer in and then putting your metal pole. It could be 2 inches, 3 inches in diameter. Really depends on the setup you're going for. But off that pole, there's all kinds of mounting systems you can use. A U-bolt to hold to the metal piping and different tracking mounting systems there. You'll see in that up close photograph, you'll see a end bracket there, again, with that lip holding down the edge of the module to keep it in place on the railing. Now, with the larger ground mounted systems, you're going to need more than one post, obviously. And so in this example, and this is just one option available on the marketplace today, this is a screw system, but you could do any kind of pier or pile driven into the ground. So this screw system, you're putting multiple points in. Again, you'll have to look at some of the structural analysis and soil analysis to dictate how many of those you drive into the ground. In this case, you have a flange that sits on top of each pier. And you see that in step 2. That flange is nut and bolted onto the top. And then that flange is where the above ground structure fits in. And so in this case, they're using a folded structure. This particular model is highly adjustable to the tilt, but there's many options out there. I think in step 4, you'll see the railing going across left to right. There's a support beam on the back for more structural integrity. And then of course the modules sit down on the railing with those various clamps that are available. Okay, another example is given on the next slide. You'll see either steel pipe or metal tubing, and you can source a lot of this locally. You don't have to necessarily buy specific equipment like I showed you on the previous slide. A lot of this can be available just right off any hardware store shelf. But there's various options out here. This one's showing again, the steel pipe or mechanical tubing, and this is driven into the ground, typically cemented in a footer. And then again, that tubing is the vertical and the horizontal support. You also have a railing system, and this is typically what you're buying specifically from a solar manufacturer. And so this railing system is going from the higher beam down to the lower beam. And again, that's what the modules are mounted to. So just to give you an idea of what some of these systems might look at, we'll go through an actual example momentarily though. What I will say is, as you know, we're not only going to touch on some of the technical aspects, but we're also going to touch on, as I mentioned earlier, some of the permitting aspects, and they kind of go hand in hand. There are specific building permits and code requirements that you'll have to adhere to, and that's going to be on a case-by-case or site-by-site location. I'm not going to be able to share on a city-by-city basis with you, because again, that's more geared towards your local jurisdiction and what the rules are there. I will make some general comments about it though, and share some of my experience. What I will say in terms of the structural, before we move into more electrical aspects, you have to account for the strength of the system. And we're going to spend most of our time here on out talking about ground mounted, but similar applications apply to rooftop systems. But I'll say when you design a mechanical support system for the PV, it has to be strong enough to hold the system up, not only from the dead loads, that would be the weight of the actual system. You want to make sure it holds that up, of course, but you also have to account for the snow loads and wind forces as well. And so your local jurisdiction, you'll have to go to your city codes and find out, talk to a building inspector to ascertain that information. But the wind force and snow loads in particular, that's dictated at a city level. And so you'll have to assess, have you met those codes? And again, that's to protect the structure of the device, not just to unnecessarily penalize you for not being up to code. But you want to design your system to support those loads. I'll also point there's potential for upward forces as well. And particularly if you have your panel tilted up really high, you're going to have a wind force that catches the bottom end of the module and could potentially, under severe conditions, pull or shift the unit around. Now, I've never seen a solar photovoltaic system lifted out of the ground, but I've seen similar things with greenhouses and high tunnels under high storm conditions. It'll pull the cement out of the ground because the foundation wasn't deep enough. And so that's some of the things you have to get into detail into. Now, there's like I said, local jurisdiction and codes to follow. But you're probably familiar with that if you've ever put fencing posts in or mailboxes or something like that. You have to dig those deep enough and get the cement in there to the right depth. So those are some of the considerations. I'll share some resources with you to help you with that. But I'll say whatever manufacturer you go with, they all typically provide some guidelines to go off of. If anything, just to keep you under warranty with the product. I'm going to share one example from Iron Ridge, and I'm not advocating or soliciting for their business or anything like that. I'm just going to share what one manufacturer and designer of these racking systems will suggest. So again, follow the manufacturer's guidelines in this, and again, align that with your local building codes as well. So, and we touched on some of those building codes and permitting requirements last week, where you can get those resources, so you can revisit that presentation as well. But I'm going to take a look at this particular manufacturer just to get an idea of some of the information you can get from them. They have a nice layout on their website, if anything, just to explore. But again, I'm not trying to sell you anything through Iron Ridge, just giving you an example. If you look at their website, they ask, first thing they ask for is your location. I've put in the address of our Western Maryland Research and Education Center where I'm sitting right now. And I put the address in there and it automatically populates all of the city code data for me, the wind speed. Actually, the snow rating was not provided for me. I got a flag on that because it did not have my snow rating available. So I had to go and get that from the city. I just went to the website for the city I'm in, and I found that I think it was 30 pounds per square feet, I think, yeah, 30. So I put that number in manually. Again, the snow load and the wind data is going to be a coding issue, a local permitting issue that you kind of need to evaluate at a local level. But I put those values into their system. The next page over, if you look in the center here, it's asking for the structure and foundation input. So that would be everything from the tilt you're aiming for, the orientation, of course, should be southward facing, and you can put in specific requirements. Now, in previous webinars, we've designed the size of the solar system, and you can just put that information directly into here, and it'll tell you some guidelines on how to support that system, how many piers or piles you'll need to drive into the ground, and that kind of thing to support the system. On the output side, again, this is a company selling materials, so they're going to provide a bill of materials and the price of those materials. I'm not saying you have to buy from them, but it is some good information you can get off the website. Again, you can look up any manufacturer and not have to be Iron Ridge like I'm using in this example, but they give you a good idea of the equipment and supplies that you'll need. They'll also point out a bit of information that they give you here on the very far right side, a number of different documents that may prove useful as you design your specific system or purchase equipment or even go through the permitting process. And so some of those are included here on the presentation. On the left-hand side, you'll see a spec sheet or a cut sheet of each component that they're telling you will work with the system that you're proposing. So, in this case, I've looked at the cut sheet for a U-bolt system, and it gives you all the torque ratings and everything needed for that part. So, I mean, you could buy through a specific manufacturer, or maybe you can piece it together from a hardware store. But again, you get some good information from going right to the manufacturers, and again, that will make sure that you stay within warranty, that you're installing a system accordingly. In the middle, you have a engineering design sketch there, a CAD drawing of the system that you've designed. There's also an installation manual, and I've included the checklist of all the supplies and the tools that are required from that manual. So again, going to the manufacturer and seeing what they recommend and going off that will be a good way to start your design for your system. Now I'll go through briefly a quick example of an installation. Here you'll see one of the early steps is to dig a trench and lay the conduit in that. Also, you might need an auger or some type of auger. I'd recommend a skid-mounted auger. It's a little easier to manage, depending on the depth that you're going. So the trench will help you get the conduit laid, and then the auger will help you get those posts in place. So the bit will work there. If you don't have that equipment, you'd have to rent it. And I'll kind of point out, as we go through this example, this will give you an opportunity to assess what part of this is doable yourself, what part you'll have to contract out, because there are a lot of different technical aspects, and there are a lot of different permitting aspects that you'll have to kind of cross to get to the finish line. And especially when we start talking about the electrical work. When you start talking about the electrical work, you have to be a master electrician to tie into the grid. That's required by law. So there's going to be parts of this that you may be able to do yourself, parts you may not. And even if you contract all this work out, you still have an idea of what's to be expected through the process and what you're going to be responsible for, what the contractor is going to be responsible for. But going back to the example, the trench has been dug. They'll typically, again, this will be based on your local jurisdiction, but they may want to inspect the trench. In this case, it needs to be 18 inches in this example. So you need to get that dug to the proper depth, and they might come out and just inspect that. It'll take a minute or two. That's not too complicated. Some of the other permitting and code requirements are a little bit more sophisticated, but I'll kind of highlight those. I'm not going to be able to touch on all of them, but I'll just touch on a few aspects of that. When you design your system, again, it's going to be based on the modules and the inverter that you select if you're doing an inverter to make alternating current. When you design the system, they'll typically recommend the different wiring and cabling that you'll need. In this case, it requires a 2-inch PVC conduit to be laid through that trench, and then the cables are pulled through that conduit. In this case, there's we're using 4-gauge aluminum wires. This is because there are 2 series out in the field that this is installed. So there's 2 rows of modules, and so you're having 2 positives and 2 negatives, and then a ground wire, 5 cables total running through that conduit. And this is just, every PV system is going to look a little bit different, but those cables are running all the way back around 400 feet back to a large string inverter. You could use microinverters as well. There's just a little more expense. In this case, the single series inverter was already on hand, so that's kind of why this system was designed as it is. But it's going quite a distance to cover 400 feet back to the inverter. So that's just how this project worked out. But I'll say, you want to be careful, especially when you're covering that kind of ground, that you don't have voltage loss. And so as you pick out the supplies, the manufacturer will typically recommend what kind of cabling and wire to use so you don't experience significant voltage drop. Another aspect of this is, those kind of local building code and permitting issues arise. And in this case, the conduit, each section of the conduit had to be glued before the cable was pulled through. So it added a little bit more complication there, that you couldn't feed one PVC pipe on at a time, but there are some restrictions like that sometimes. So as you see, even if you're an electrician, a certified electrician, there'd be a lot of local issues that you might have to deal with as they arise to ensure that everything's up to code. Now here's a look at the structure actually being put in. So, this was done with bags of cement. I would recommend, getting a cement mixer, renting one of those if you're doing a system. It really depends on the amount of work you want to put into it and the size of the system and how many piers you're putting into the ground. Yeah, it's going to take quite a bit of cement depending on how many you're putting into the ground. This is using 1.5-inch galvanized steel pipe for the vertical and horizontal beams, and then the railing is going from the high to low point with the modules attached to that railing. So again, all of this has to be designed to support the structure, again, that is dictated by not only the weight of the system, but soil conditions, wind, and snow loads that are expected in your area to stay up to code. Now, where the electrical goes, it travels all that distance across the property back to the main residence, and the inverter here is receiving anywhere from 300 to 600 volts. And in previous sessions, like I said, we learned how to size this system, so you can revisit that. But this system receives 300 to 600 volts DC direct current, and then converts that to 240 alternating current volts. I'll mention one thing here is since aluminum wire was used, you have to put a little gel on the wiring to prevent the oxidation, and that's going to be important for the longevity of the system. If you use copper wiring, you're really not going to have that problem even when the copper oxidizes, but little things like that will pop up, and you'll be required to do that to maintain adherence to local building codes. So the output from the inverter here goes into first into a sub panel that was installed. A new sub panel had to go in because there was already a small PV system, rooftop system on the residence. And so that sub panel combines those two systems, the rooftop and the ground mount system. And that all feeds into a main service panel. In this case, a 50 amp breaker had to be added to the main service panel. Again, you're going to need an electrician to do this. But that's kind of how that system works. There's obviously a lot of code requirements for that. And we're not going to have time to get into the details of that, but that's kind of the general idea. There's a few more aspects to this. Actually attaching the modules to the railing now, and the railing was purchased from a retailer, a solar retailer. Everything else was kind of locally sourced, but the railing attaches there. You'll see at the bottom of the modules the C-clamps holding the railing to the steel pipe, and it also needs grounding. So in this case, driving an 8-foot grounding rod into the ground, and then having a copper wire attach the modules to the grounding rod. Another issue that might pop up is accessibility to the panels. For larger systems, of course, there's fencing and other things. Smaller systems, you could build a fence depending on what your building permit requires, but you'll have to prevent access to dangerous parts. You're dealing with a lot of high voltage. In reality, you know, the cabling probably isn't too dangerous. I'm not telling you to go play with it and touch it, but if the connections are made good, in this case using MC4 connections between the cabling, you're probably not going to get electrocuted just walking past it, but just for safety, they do require protection over the system. Like I said, a fence could be installed, but in this case, just a simple hardware cloth like a chicken wire was used, a very inexpensive method just to cover the back of the module so the wires are not exposed. But there's a number of other permitting and technical issues that we could get into, but for brevity's sake, we'll just kind of move forward. But all in all, the whole project has to be inspected before you can do any connection in terms of net metering and connecting to your utility. So there's an interconnection agreement that you'll have to go through, and they have to see that everything's been passed according to code. So again, you'll have to look at a local level to ensure that. I'll kind of highlight some of the main aspects of that process, but you know, you're going to have to obtain the building permit. You're going to have all code compliant materials. So they're going to want to know, is all your equipment, is your inverter certified with Underwriters Lab and that kind of thing. So again, you'll have to verify some of this information going forward. I've included some comments here on what may be required in the permitting process. This is not an all-inclusive list, but that could include all the details and specs on your actual PV module and the inverter that you're going to purchase. They might need a photo of your supply panel and the meter, the line drawings, and I've given some examples there on the right-hand side of the layout of the system and the different components and how those will work together. A site map laying out all those different components. And so again, this might seem kind of overwhelming, but again, you're not necessarily going to be doing this all by yourself. You're going to have work alongside with an electrician or a contractor or somebody to help navigate this and to ensure that everything's good with your local jurisdiction and building permitter. You know, the engineering for the mounting system and other things as well, and all the equipment needs to be labeled to get final approval. You know, you'll have to have everything listed as a safety disconnect switch and everything else. So, you know, in an emergency situation, or if you need to cut the power, everything's clearly labeled and documented, and that'll all be a part of the permitting application. So as I said over and over again, this is going to be a local case-by-case basis, and working with your a building inspector and a permitter to kind of navigate this. You have to look at the building codes. It could be a more local level of subdivision covenants or other things like that. It could be looking at homeowner association might have specific rules. Maybe they don't want the panels visible from the street. So, you know, you might have to put it somewhere that's a little more discreet. If a historic home or ag preservation, those are all specific circumstances that might arise that you'll have to account for but again, a little beyond what we'll be able to cover today. As you consider moving forward with an installation, you know, as I mentioned before, more than likely you're not going to be able to perform all this work on your own. So regardless of how much of the work you contract out, or if you have a contractor perform all of the work, here's some keys to kind of help you decide on a contractor. And we'll talk about what's included in the bids momentarily, but you know, if you're looking at various contractors, you want to look at their experience, if they're a reputable company, if they have experience working with the type of system you're interested in installing. You know, if they've only worked on rooftop systems, you may not want to hire them for a ground mount system. Okay, so specific equipment and things like that. So do your research, find out if they're well equipped to do the job that you've hired them for. Look at warranties and system commission and other things, but I want to touch on some of these other factors here. Licensing and certification. I'll say solar contractors have to be certified through the Maryland Home Improvement Commission, and you can get their license number at the website that's provided on the slides here. If you miss it now, again, the video and the resources will be posted online, but you can go on their website. You can see if they have a license number, if they're qualified to work in the state of Maryland. That said, there's no special certification needed to install the PV system itself. So technically you could do it yourself. One caveat, you have to be a certified or a licensed electrician to install and tie into the grid. So that's one factor to take into account. Other certifications may be applicable. One in particular is the NABCEP, the North American Board of Certified Energy Practitioners. This will be important if you're applying for certain rebates and grant programs, and we'll get into this more next week on the economic side. But some of those financial opportunities require a certification from NABCEP. So a lot of the contractors in the state of Maryland will have at least somebody on their staff with that certification. Again, you can go to the NABCEP website and look at their directory for who's certified in that. Insurance is important as well. Liability, workman's compensation insurance, or if they've had safety training. Basically, you don't want anyone to get hurt on your property, and you don't want to be held liable for that kind of injury. You can also look into the reputation and reliability of the company by seeing their involvement in the trade association, and this is typically the Solar Energy Industries Association, SEIA. I think I have included their contact information on a later slide, but you can search their name as well. If they're a part, you know, a longstanding member of that association, it might speak a little bit towards their reliability and reputation. But the Better Business Bureau may be another option to, especially if there's a complaint against that contractor, you might want to look into that. I'll come back to system monitoring. I know I'm kind of low on time. I want to have time to get to your questions as well. So if you do have questions, put them in the Q&A and we'll address those momentarily. To get you help started on finding a contractor, I'm not, again, advocating for any company. I'm just going to provide contact information for those. In fact, you can find the contact phone number and website for many contractors on our site, Maryland Energy Extension website. Again, do the research on your own, investigate it on your own, and see who would be a good option for you to move forward and get a bid if you're interested in moving forward with that. The SEIA Trade Association will also be one that has a directory of solar installers. Of course, you can look in the phone book or online. One website I've included is Solar Reviews, to look up the reviews of different installers, and that could be a helpful tool to get started as well. Bids, if you get a bid, I would recommend getting at least 3 bids. I mean, this kind of common sense applies to any bid that you receive for any kind of contracting work, but we'll talk in terms of solar photovoltaics. Make sure all the installation costs are included, the hardware, the labor, and everything else. Include the system specification. So how big is the system in terms of the power, kilowatt power, all the make and model of the equipment, and also you want to look at how they've estimated the energy output. They're going to tell you that your system will produce a certain amount of energy, and you want to know how they've got to that number and ensure that that's a reasonable estimate that they've given you. Questions you can ask is about the warranty on the system or the components, what's included in the cost estimates, especially when you're talking about have they included any of the federal incentives or state, local incentives already. You know, if they've included that, if the offer looks too good to be true, they may have included some of those incentives already to lower the cost. You want to know if they're going to handle those for you or if you're going to have to handle those. With any lease or power purchase agreement, look at the payment over time, your monthly payments and that kind of thing. I'll touch on that probably next week. But a quick note here, just comparing bids. If you have multiple bids, like I recommended, you probably want to compare them on a per kilowatt basis. So that's the first note I've included here. If you get two bids and they're different sizes, one would be maybe a 5 kilowatt, one would be a 4 kilowatt system. Just divide the cost by the size of that system and you get the per kilowatt basis. And so that's one way to compare two different systems. You also want to make sure that you're comparing the same alternating current to alternating current or direct current to direct current, apples to apples. So if one bid comes in the form of direct current and another comes in alternating current, you want to make sure that you're compensating for that and comparing those. With the interconnection agreement in Maryland, it's done in direct current, so I typically use that convention. Other factors will play into the decision between bids that you might get from a contractor, what type of technology they're using, their company reputation, and other things as well. I'm not going to go through all this because I'm kind of out of time, but if you're comparing bids, look through all these different factors. You want to make sure that you understand the entire contract. You want to make sure that everything that was agreed on verbally, don't just go with a handshake, make sure it's written in the paperwork before you sign it. If you don't understand anything, get the answer for it. You can get legal help if you need to, but you want to look at all these different aspects, the warranty of the equipment as well as the workmanship. You want to know how long is it going to take them to construct the project. You're going to want to know all those factors. I'll point out one additional aspect, subcontractors. I put a note on here about subcontractors. If they are hiring a part of the job out to a subcontractor, you want to know who's doing that work and who's going to be supporting that warranty. Is it going to be your main contractor or is it going to be the subcontractor? Those are some of the details that you want to get into and make sure are included in your bid. Again, I'll probably touch on these topics at a later point, but just to introduce them now. Being that we're out of time, I'll kind of just skim through some basic functions of operation and then I'll go to questions. There's not a whole lot involved in operation and maintenance. It's pretty much a set it up kind of system and let it run its course for its lifetime. There's a couple things I'll note though. If you have shading, maybe a new tree or a tree has grown and starts to shade your panels, typically easier to prune that tree than to move the whole system. You really don't have to worry about dirt and debris for the most part. The rain will typically wash that off. We live in a wet enough environment that works well. So some people wonder if they'll have to scrub the panels, not necessarily. Of course, if your panel is broken in any way, if the glass is fractured like is happened with these rocks on this module, you want to make sure to replace that module. I've heard of people trying to repair them. I don't think that works really well. I haven't really seen that firsthand, but probably want to replace the module. Even if it's a small fracture, make sure there's not water penetrating into the module and causing any corrosion. If the panels are shifting or anything like that, you want to make sure the nuts and bolts are tightened. The wiring should be installed up to code. Should be restrained or restricted access, zip ties and things like that. But make sure you're not having any rust or corrosion on the connection points. Again, if you're using good connection points, you won't really have that problem. Sometimes animals can get into it if you have problems with rodents, and there's ways to protect against that as well. But what I will say is if you have a monitoring system, some way to monitor the performance and either install this yourself or have your contractor look into options for you. But if you have any way for them, for the contractor or installer or for yourself to monitor the system, you'll kind of get an idea when problems might arise. And so that's some of the things. Again, a couple other things, batteries, and we'll talk about that another time. Water leakage into your roof, you'd have to reseal that. Not too common, but that's a possibility. Even if you maintain your system really well, you'll still have performance drop over time, and maybe 0.5% per year on average, but that's just how it works. And if you drop significantly, you may have the product under warranty, that the module could be replaced. The inverter will also have performance drop. So just kind of look at that over time and see if the efficiency has dropped enough to replace a system. With that said, I'm going to launch a survey or closing survey. And as you do that, I'm going to pull up the questions. And if you're able to stay on, I know it's kind of late, but if you have time to stay on, I'll answer your questions.